I'm Michael Rogers. I'm here ostensibly, I guess, because a long time ago I created a project called Windmill with Adam Christian, who's now at Sauce Labs, which was a Selenium competitor that did some really cool stuff. Then I worked at Mozilla for a while. I created the Mozmill project there, which we use for a lot of the in-browser testing and testing Zool, which was like really, really fun to implement. And also while I was there, I started to get really into CouchDB because we had these problems where we're taking in these huge amounts of test results and we couldn't really figure out what to do with them. And then I ended up going over to Couch One as the first employee and working on CouchDB stuff. Also, I started doing a lot of Node.js work. So if you have any Node questions, just come up to me. Totally unrelated to this talk, but you can come talk to me about them. And right now, I'm actually the developer advocate at Yammer. So if you use our API, you should definitely be speaking to me. All right, so this talk essentially is going to be about CouchDB. I thought about doing a little bit like more of a general talk about test results, but then I decided that's stupid because you should really just put all your test results in CouchDB. I'm not even going to lie. Like, it's perfect for test results because what you can do is you can just take all of the information that you're getting about a test run and shove it all into a big JSON document and just store it. And then later, you can figure out what kind of questions you want to ask that test data. That's really what you want to do, right? You want to log all of the possible data that you can, and then in the future, be able to ask any question of your test results that you want, and not think about all of your test questions beforehand, like you have to do with a relational database, or any database where you're going to have to think about the indexing scheme up front. OK, so whoa, what happened? Hey there. Doesn't like that one. OK, so big thank you to Henrik Skupen. He is at Mozilla, and he gave me a database with a bunch of Mozilla's test results in it, and that's what I used today to build a little application that I'm going to go through that just sort of exposes information about those test results and answers some pretty cool questions. I'm also using a special CouchDB branch. It's called the Sammy branch. It was started by me, and it's now maintained actually by Benjamin Young. And you can find it on GitHub there. It's going to be the next version of Futon, which is the basically the HTML sort of AJAX application that you use to explore CouchDB. Also, there's an application that I wrote called Node Couch App that's just a very simple way for you to write couch apps in CouchDB. Couch apps are just, they're basically just HTML and JavaScript that are statically hosted inside of CouchDB and served out from it, so that you can make requests back to it without having any layer in between. No Nginx, no Python, no Ruby, no Java. Like, you just talk directly to your database from HTML and JavaScript. And also, I'm going to be using Sammy.js a lot, which is just it's a very simple way to define routes in client-side JavaScript and then do hashtag routing. And you can read about all of those. They're very easy to understand. You can troll through the source and figure it out in like 20 minutes. OK, let's get a move on, because I'm not going fast enough yet. OK, so this is CouchDB. This is the first view that you see in Futon. And the database that we care about is this database right here called results. So I got this from Henrik. I actually killed the replication of this database like about a quarter of the way through because it's way too big. And I wanted to finish this like today. So we're working with about 3,000 different documents. Those are each individual test runs. And the test runs basically look like this. They're just they've got a report type because there's multiple different test types inside of this database. It's not just test runs from Mochikit or Mozmill or Selenium. There are update tests. There are add-ons tests. There's all kinds of different test runs that can happen. And they're going to vary slightly in their format. But certain things aren't going to change. Like, Henrik is really good about having this test results array. So this is every individual encapsulation that he could find for a particular test. So this is actually the name here is the function name, and then this is the file that it came out of. And then any failures or passes are going to be in there. It turns out that there was actually nothing inside a setup module to pass or fail, so there's no information in that one. But you can actually explore this a little deeper. There's a lot of information in here in the system info. Also very, very important is this build ID, because that build ID is the one thing that we can rely on to be numerically sortable. We can't rely on the start time of a build or the start time of a test, because those can get out of order from when an actual check-in happened. But a build is started and a numeric build ID is kicked off for every individual new check-in. So even though we have this check-in hash up here from Mercurial, where did it go? It's like right, no, I don't even know where it is. But there's a hash somewhere in there for the check-in ID. Yeah, application chain set, here it is. So that's a hash for Mercurial. That's not sortable. We can't sort that like numerically inside of an index. So it's very important that we have the build ID. These are the views that I built out. These are some indexes that we're going to be working with. In CouchDB, you create these special documents called design documents. And in there, you can define custom indexes like this. You just have a views hash, and then you have different named views, and a map, and an optional reduce function. You'll notice that you can actually write a JavaScript function to do reduce, but like never do that. If you're doing that, you're probably doing something wrong. There's a set of built-in reduces that are just like this underscore sum is a sum reduce that's built into CouchDB, and they're much faster. And if you're not using those, you're probably doing something wrong. And just because these functions are really hard to read, I actually have some better notes here. So we'll go over these one by one as we go through this application. But the first few are really simple. There are different report types. So we're definitely going to want to be able to look at how many individual test runs we have for a particular report type. So this here is just going to emit 1 for every document in the database that has a report type. Because some documents might be some random log, or this application is an actual CouchDB document, so you don't want to emit on those. And then when we're looking at the number of tests in for a particular type, we can actually do that by, again, emitting the report type, but rather than summing just 1, we can sum the number of actual tests in the results array there. And we're going to get into this guy just a little bit later. It's a little bit more complicated. So this is kind of the essence of Node Couch App. You just create a little document here, and this all goes in the database. And you can run a script that will sync the attachments directory to CouchDB every time that you change anything. And as you can see here, we have these rewrite rules. This is so that you can get Nginx out of the way, get anything out of the way in between you and CouchDB, and actually do all of your rewriting logic inside of CouchDB itself. And you basically do that by, you go into Futon here, and there's this configuration pane, and you just create this little guy called vhost that points at that rewriter for this vhost. And then I just have a little, in my etc host file, I route results to localhost. And boom, we're done. Actually, it doesn't say that right now. Oh, it does, because I put that in there. So let's kick that off. We just start a sync here. So every time I change anything inside of this little HTML and JavaScript directory, it's going to sync back to CouchDB. I don't know why I'm looking at that screen over here. I have the same screen in front of me. That's kind of stupid. All right, I did it again. I should take a shot every time that I do that. This talk will get out of control. It'd be great. OK, so yeah, if I take this hello world out for a second here, I can actually go back. I have TextMate save on application change, so it automatically saves. And then the CouchDB script will pick that up, and it'll go. And you can't hear it, but there's actually, it makes a little sound. And if I turn my volume up all the way, I can actually feel it vibrate on the keyboard. It's awesome. So then I know when to actually refresh this page, and oh, boom, it's gone. OK, so let's go into the site here. Again, this is like all code that I built out today, so you can kind of tell how quickly you can go through a database and kind of figure shit out and play around with your test results. That should get a little bigger. There you go. That's bigger. OK, so we're going to clear out the body. This is a single-page application, so clicking around in it is only going to change the hashtag. So we actually want to clear out the body on every page refresh. So that's what this little call here is. And then we're going to make this call. So API is one of the rewrite rules that I have that routes back to the database root. So we're just doing a view query here to this types view that has a sum reduced that we looked at earlier. It's right up here. And we're going to say group equals true. Group equals true makes it so that everything that emits the same key is going to be grouped into a single key. And then all of the results there are summed for that particular key. Pretty simple. And then when we get that response back, we're going to iterate over every row. And we're going to create like a really simple little index here. Let's see what that is. Oh, and then I'm referencing, yeah. OK, we're just going to uncomment all of the routes for right now, because that's going to make my life easier. OK, there we go. So these are all of the different test types that are in this database. There's actually a lot more in the full database, but like I said, I didn't replicate the whole thing. So yeah, we've got Firefox add-ons tests, and they're general tests, which I believe are actually MochiKit tests, or possibly Mosmill tests, I'm not sure. And then they've got their L10N internationalization tests and the update tests. So let's drill into here. Oh, and nothing happened. And nothing happened because I haven't uncommented that out yet. So as you can see, like all we did was change the hashtag to be this Firefox general here. And I've just got to uncomment that out. So here we have by type function. And then down here we have a route rule that just says anything that isn't new fails, we're going to call that type and then send it to this app by type function. And then boom, here's that function. And you can pull the params from the URL off of this .params. Pretty simple. Now we're going to make a new view query. We're going to hit that types one again. It's actually the same view that we just hit to get that summed up group reduce. But we're going to say don't reduce, just treat it like a normal index. And then I'm going to query for a particular key. So it's going to hit that view again, and it's going to just say only give me the results that match this key, which in this case is going to be this type here, which is the thing that we pulled off of the URL. And then we're going to iterate over each of those, and this time we're actually going to grab the ID for the row, which is actually the document ID for that row, and we're going to create another little index of all of the tests that match that particular thing. Oh, I didn't save it yet. You didn't hear it, but the sound hadn't gone off yet? All right, so here's some test results. They have these really big, fucking ugly, like, doc IDs, but that's them. So let's check one of those out. Oh, and nothing happens. And the reason that nothing happens is because we don't actually have a route set up for that yet. But what that's going to do is, like, see, this is the actual ID for that. If I swap that out for API, we can look at the full document here. This is actually just a Chrome plugin that pretties up the JSON, but that's about it. So let's go back to that. And let's see here. Actually, no, this guy. Oh, I keep blowing into the mic. It sounds terrible. All right, show doc. All right, we're going to uncomment that out. And we have this guy down here that says anything /test/ID is going to go to show doc. And show doc is this nice little function up here. And so here we grab ID off of the URL params, and then we just actually get the document for that ID, which is that it's this exact query right here that I'm doing. And then we're going to iterate over each of the results in the results array to do something cool with later. Oh, no, sorry. Actually, right now, we're going to show just failures at the top. And then at the very bottom, just for good measure, we're going to JSON stringify the whole document and pretty it up a little bit and display it at the bottom just that you can get a nice view of it. And now that that's saved, oh, look at that. Oh, man, there's no failures in this one. Let's find one with failures. It won't take that long. Oh, I broke something. Cool. Oh, the failure name is S because I broke the file name. OK, that's cool, I think. Yeah, it's fine. I don't really care. OK. Let's just change that to that. That'll fix it. What? What? Oh, that's not right. Again, I need to take a shot. All right. So that's the full test name. Oh, see, I have a bug in my code. That's OK. So yeah, here's the full test name for all the different tests that actually failed. This is actually the file name, not the individual function name. So we can really easily just kind of pull out all the failures, show information about them. If you look inside of the document here, let's find one of these failures real quick. I'm just going to cheat and search for it. Yep. Whatever. Passes. I can't find these stupid failures. These are not failing as much as they should be. Well, I guess that's good for Firefox, though, right? I mean, they did just ship. Glad that there aren't a bunch of failing tests inside of it. Anyway, we could pull a lot more information out if I was less lazy. But for right now, let's do something cool. One really interesting question that I like to ask is if these failures are new failures or not. In other words, have these tests been failing since the last time that we ran this test on this platform with the previous build? Or are they brand new? The reason is that I'm sure that you guys, everybody here who deals with test results has dealt with this. You get like random oranges. And like, how do you even track random oranges, right? And how do you, and when you have tests that fail all the time, like you actually like just went, okay, well we have a new release, we have like 80 tests failing, we clearly can't look at them all. I want to know like, what are just the new tests that are failing? This is a really, really good question to ask. When we started doing mobile Firefox, which was shortly before I left Firefox, Mozilla rather, we had so many failures on the mobile tests that we couldn't possibly look at all of them. So we really only ever cared about what are new failures. And then when we were hunting down random oranges, what we really wanted to do was a lot of analysis on the database to go, what are the ones that are new failures once and then never fail again the most often? Because those are clearly like the tests that are really brittle and don't show up enough. So here's how we do that. We have this view called new fails. And it's a little complicated. So we iterate over every result in the result set, right? We do this little thing here, which is where that S bug came from, by the way, earlier today, where we actually strip off all the temp file crap that goes in front of the test file name. And then we do this huge emit right here. And this is like kind of hard to read, so let me just break it down a little bit. OK, so in CouchDB, you can actually emit full JSON values as your keys. And they sort a little differently than if they were just a string. Basically, if you have an array like this, each element in the array gets sorted, and then the next element in the array gets sorted. They don't just get compacted together. So in this case, we can sort by the report type, the system, which is actually like Mac or Linux or whatever it failed on, and then we munch together the file name and the actual test function name in order to get one thing that's sortable for that particular test type. So now, if we look at this index inside of the database, every test that ever ran for this platform of that name is going to be grouped together. And then they're going to be sorted secondarily by the actual build ID. And so if we make that query descending, if we set descending equals true, that will basically reverse the sort of the entire index. And if we query for a test that we have that we know failed, the next one after it is going to be the previous build ID of that same test for that same platform. And then here, we just emit whether or not it was a failure or not. So if the failure length is 0, it's going to be false. So if it's not false, then it's true. Very simple stuff. And then this is like a really nice, convenient little function down here. This just emits the start time for every document test run if there were any failed tests. Haha. So now let's uncomment out some stuff in here. So we do one more query. We do a query here where we create that start key out of just the build ID, like all the stuff in the build ID. And then we do limit equals 2 and descending true. And then we give it the JSON stringified start key inside of that query string parameter. And then what we do here is, if for some reason this is a new test, or if there's just not a lot of results in the database, the next result would actually be a different file name than the previous one. So we just like block right out of this and don't emit any failures. And then what we do is we append to this fail up here that we created, this element, whether or not this test is a new failure. All right, so let's let it. I just heard it on my thing, but you didn't hear it. All right, now refresh. Oh, look at that. They're all new failures because I have a bug in my code and it's emitting the wrong file name. But let's look at something a little more interesting. Let's go to new fails, which doesn't work because we don't have that route right now. But we will in a second. All right. So this guy queries new failures, or has fails, sorry, with a limit 10 because this gets crazy on the queries. Then for each row, it's going to create an element, and it's also going to fetch that document ID and iterate over the result set like we did before and build out this start key, and then make all those queries to figure out if all of the failures in those tests are new failures or not. And let's go back to this page now. Oh, it just, no. OK. So check this, like, oh, wait. Let me refresh it and then go. So there's like so many crazy requests right now. So it gets every single document. It goes and does like a query for every individual failure. And then, boom, it's appending new for all the tests that have actually failed. Now, clearly, I have a bug, and so some of these aren't going to be entirely accurate. Like that one was all true. It's clearly not true. But but like, where's one that's more interesting? Actually, why don't we make this easier on ourselves? Why don't we come up here and right after this do row dot, oh no, it's not there. Sorry, it's going to be down here. Here we do test dot append row dot, no, doc dot tests failed, I believe. No, maybe. Let's try that. Yep. Okay. It's a live demo. Let's screw around a little bit. All right, yep, okay. So now it's showing us how many tests there are, and then right next to that, how many of those failures are new. So it looks like that bug is actually causing most of these. But like this guy here, haha, finally. A few of these are new failures, and a few of them aren't. Some of them have been failing for quite a while, and some of them just started failing for this particular build. Which is really interesting. I bet the guy who is hunting down like all of these failures would like to know that he doesn't have to carry about this shit right here, because these are new. And, whoa, I keep blowing into the mic. It's crazy. And that's about it. I mean, it's a little short because this shit is really easy. You just shove everything in CouchDB, and then you start thinking about questions that you want to ask and creating out indexes and doing crazy queries. A lot of these pages, like as you can see, create like 1 million queries. I mean, that's where like putting something in front of CouchDB and just caching these pages does that. Or using, like a lot of the time, you're actually just going to do some analytics, right? You're going to want to just know, I'm going to create like 4 new indexes and then do a bunch of really insane queries on them to figure out historically what are the tests that happen to fail the most, or what platform do we get the most random oranges on, stuff like that. Any questions? So all of the Mozilla code that they use to look at their test results is open source, so you can go through that. But like, I mean, my results aren't going to look like your results, man. Like, I mean, you're going to have a hugely different set of concerns. You're going to log different information that you care about. Like, you're going to have to like actually think about this problem and write a little bit of code. I mean, anybody else? All right, all done.